Hello guys, so welcome back to our lecture. This is basically the last video on the lectures. Then we're gonna go to the VHDL lessons to show you how to implement such, synchronous circuits. So in this example, this is basically analysis example, okay, in which you have a circuit. You start from the circuit, the implementation, and try to guess, the function. So the major steps is as follows. First, you get the equations out of the circuit that is given. From the equations, you build the state table. From the state table, you build the state diagram. So let's do that. So we have here a very simple circuit. Just one flip-flops and two XOR gates. So what we need to do to get two equations. The input of the flip-flop is the equations for the inputs of the flip-flop. Here you have just one input, which is D. So one equation basically, and the equation for the output. Okay. To do that, you need to know, especially for the output, you need to know if it's a melee or more circuit, and this is really useful to know or to get or to check on your equation for the output. A in that case here the output is called A. Okay, so if we look here, the output of the flip-flop Q is just connected to the output of the circuit A. So this is basically a more circuit. A is only a function of Q, which is basically equal to Q. Okay, so A, that's a more circuit, so and A is equal to Q. That's the first equation. A second equation is D. Okay, so let's check. Here you have X XOR Y, and here is Q. So the output here is basically X XOR Y XOR Q. So D equal to X XOR Y XOR Q. Very simple. Okay. Then we build, based on these two equations, we build the state table. Let's check how. So remember, A equal to Q, and D is equal to X XOR Y XOR Q. So you start here basically with three columns, X and Y and Q. Okay, and this is the first example in which we see two inputs, not just one input, X. And again, this is, in general, you have inputs. How many? Based on the application. Generally, you have outputs. How many? Based on the application. Okay, we see circuits with just one input. We see circuits with no inputs at all, like for example, the count up, counter with output connected to a 7-segment display. Okay. So these you can consider as your variables now. Okay, X, Y, and Q. So they have eight combinations from 0, 0, 0 until 1, 1, 1. Okay. Then, since you have the equations already for A and Q, then you build the D column and the A column. A is really simple. Just copy and paste that column here into that column. That column is copy to that column. Okay, look, 0, 0, 1, 1, 0, 0, and so on. Now for the D, D is XOR of three variables. So, again, apply the rule. If the number of ones is odd, D will be 1. If the number of ones is even, D will be 0. So here you have no ones, you have 0 ones, and it happens to be 0 is an even number. So D is 0. Here you have just 1, 1, which is that guy here. So D is 1. Here you have again 1, 1. So D is 1, and so on. Okay. Finally, you build the Q of T plus 1. And for D flip-flop, it's extremely simple. Just copy and paste the column of D into the column of Q plus. So just copy this into here. Copy and paste that into that column. Okay. Finally, based on that, we build the state diagram. Okay, state diagram. So it's the solution is here, but let's do it on ourselves. So you have here one flip-flop. So you have just two states, because the output might be 0 or 1. There is no other options. So you have two states. One is called 0. One is called 1. Okay. So let's remove all that mess here and try to build the state diagram out of the state table. So you just look here for the inputs and the current Q, the current state. So when the input are 0, 0, and the current state is 0, so the next state will be 0 as well, so the state will not change if the inputs are 0, 0. And when the present state or the current state is 0, the output will be 0. Because this is a Moore circuit, so the output doesn't depend on the inputs X and Y here. The output A only depend on the current state. Now, when the inputs is 0, 0, and the current state is 1, the next state will be also 1. So the state will not change when the input is 1, 1, and the current state is 1. And the output, if the current state or present state is 1, the output is also 1. Okay. When the input is 0, 1, and the present state is 0, the next state will be, so will transition here. If the input is 0, 1, we're gonna go to 1. I will not mention again the output in that case because it is the same state, 0. So we did before that. We know that when the state with the current state or present state is 0, the output will be 0. When the present state is 1, the output will be 1. So henceforth, we will not do that. We already have the output in each case, okay, for each state. Now, when the inputs is 0, 1, and the current state is 1, the next state will be, so again, when the inputs is 0, 1, but the current state is 1 now, so we're gonna go to 0, the next state. When the input is 1, 0, and the current state is 0, we're gonna make a transition. So here, 1, 0. So you would switch from 0 to 1 or from state 0 to state 1 in two cases. When the input is 0, 1 or 1, 0. This is the first time also to see that we're gonna switch, in two different cases. And that's, it's not a unique, it's something, based on the application, you might have this. No problem at all. Again, when the input is 1, 0, and the current state is 1, we're gonna also switch. So again, we're gonna switch from 1 to 0 if the input is 1, 0. Finally, when the inputs are 1, 1, and the current state is 0, we're gonna stay in the same state. So again, we're gonna stay here in the 1, 1 case. Final row, current state is 1, 1, current input is 1, 1, current state is, or present state is 1, so the next state is also 1. I'm sorry, this was 0, 0. Yeah, this was 0, 0, this case here. So now it's 1, 1. Also, we're gonna stay the same state. So it's really simple, state diagram. Okay, guys. Yeah. So now we take many examples on design. We take many examples on analysis. Of course, analysis is much easier than the design. In the design you must get the state. Of course, once you get the state diagram, okay, and design the state diagram basically, then everything will be straightforward. But it's not that easy each time. But for analysis, since the circuit is implemented, you just get the equation very easy, okay, and straightforward afterwards. Even getting the equation is also straightforward. And now, how to code this in VHDL? Okay, how to code basically synchronous circuit in VHDL? Okay, there are many ways, and we're gonna explore them in the next VHDL lessons. Okay, guys, thank you very much for watching this video, and see you in the next lesson. Bye bye.